Okay guys, so we're going to be going through the U1L1 notes within this video. Again, this is just going to be a couple of the slides. You're going to make a couple note cards, and then that's it. That's going to be your assignment. So I just want to really quickly wrap up with the lab because you should be finishing up the lab first. So really you should be up through the application problems, or that's where at least you should be able to get everything else done today. If you don't have the application problems done, and you can get that done tomorrow in class, and I'll help you a little bit. But I wanted to give you guys a hint for these last two application problems that they should use your math model. And we talked about that yesterday in class. You should have already gotten your math model. You want to keep in mind when it says how long would it take your buggy to travel 12 meters. Think about how long, what variable that is, and 12 meters, where would that go? What variable is that? Number one should not be too hard. Number two, it says if your buggy was in a race with another buggy that had twice the velocity of yours. So you should know your velocity because something from your graph tells you your velocity. At what position would the two buggies align if yours started at 15 meters and the other buggy started at 0? I might need to help you with this one, but I want you to try it in class with your group if you can. A hint is we want to know at what position are their positions the same. If I say what position would they align, I want to know, okay, when do they have the same position? So I'll help you with that one in class a bit tomorrow, but try it. Yeah, and if you can't figure it out, that's okay. Don't need to turn your lab in today. It's not due until Thursday. So let's go ahead. We're going to start looking through U1L1. So you will be needing 1, 2, 3 note cards, just FYI. Remember, they're at the front of the room. You can grab them, yes, because that's a part of your assignment is to make your note cards. So lots of key terms that we're going to fill out. So this unit is all about kinematics. Oops, not this way. Switch this here, sorry. There we go. This unit is all about kinematics, which is the study of the description of motion. I'm just going to kind of talk through this, guys, and anytime you need to pause the video to copy stuff down, you can. But that's, again, kinematics is motion. How do things move? So a lot of what we're going to be doing in physics. Now, for right now, for this unit, we are specifically talking about one-dimensional motion in a straight line, or we do talk about parabolic projectile motion, yeah, but that can be kind of broken down into straight lines. So this is really just one way. We're not doing like three-dimensional type stuff. Now, when we talk about these things, some other vocab you're going to see is reference to a system. And a system is just a collection of objects that interact with each other. So I can talk about, for pool, for example, all of the pool balls. I can call one ball an object, right? Or all the balls together, if I hit my cue ball into those balls, I can talk about the system of balls, which is all of the balls together. Now, two kinds are rigid, which means they don't move. You can consider your body to be a system of, parts that move together, but for the most part, my arm is not going to detach from my body, right? Or not rigid. Again, like the cue balls, I can still call it a system, but when I hit them, they're going to go off in all these different directions. We'll be referring to center of mass often as well. We can treat a system as a single object with a center of mass if we don't care about how the individual parts are moving. So for example, again, our body has arms and legs that can move independently, but really what we care about for a human is how does their center of mass, which is like, right here in our gut is where our center of mass is at actually. We care about how that moves, and so we can kind of ignore the other parts we don't care about. So you will hear this phrasing often, center of mass system. We're going to delve deeper into that later. Now, two important quantities we're going to be talking about. So if you guys could pause the video, you're going to need 3 note cards total, but we can go ahead and do these ones. When you're ready, come back and we can make these note cards. Okay, so on the front of the note card, I want you to put vector quantity, yeah, and then flip it over to the back side and then copy this down. I'm going to talk about as you copy, but you can pause if you need to. The definition of a vector quantity is any quantity that has magnitude, which is a number, and direction, the sign, or the angle. So these are all examples of quantities. Velocity, acceleration, momentum, they all measure things. That's a quantity, right? Distance is a quantity. Time is a quantity. Anything that represents something we can measure. So here's a specific example of a vector. A vector is, again, any quantity that has direction and magnitude. So a velocity of -3 meters per second. We should know velocity does mean speed, but we'll write that down a bit. Has a magnitude of 3. So the magnitude is 3. And a direction of negative. That means I'm traveling in the negative direction, right? So we're going to talk more about this in class. I just want you to copy down. This is on the back side. Vector quantity. There's the definition. On the front, oh wait, I'm recording a video. On the next card, go ahead, you're going to write scalar quantity. Yeah. So a scalar quantity is any quantity that only has magnitude. So this is any measurement of something that doesn't have a direction. So time doesn't have a direction, right? Time only goes forward. It has no direction. Distance actually doesn't have a direction either. We're going to talk about that. Mass doesn't have a direction. Energy doesn't have a direction. Anything it doesn't make sense to have a direction, we call it a scalar. So once again, if it has a direction, we call it a vector. Yeah. If it doesn't have a direction, we call it a scalar. Have those two cards made up. We're going to talk more about that in class. So let's go ahead and talk about position. We're going to fill in these blanks here. So position is the first super duper important quantity. And position is the location of an object in regard to origin. So we talked about in the buggy lab, your position was where is it at, where is it at, where is it at, where is it at? Yeah. If I'm 10 meters away, 20 meters away, 30 meters away, it does have magnitude and direction, so it is a vector quantity. No, you're fine. Sorry. No, you're fine. I'm sorry.
Oh, no worries. Take your time.
Okay.
Just like,
You're totally fine. I just was scrambling.
it doesn't work, so it's not your fault.
Oh my goodness. I can leave a key with you, or if you want to run to the office and see if they'll give you a
I
key.
could run to the office if you want me to. I don't know, but I tried to.
Oh, this is the gym.
Oh, is it?
Oh wait, no, you need 2 keys. So actually, I lied. This is for so I have 2 rooms. Okay. I'm thinking my schedule. During my 3rd hour, this will go to the bathroom.
Okay.
You need a key 6.
Time or ask.
Yeah, this is the answer. Yeah.
Okay, I'll do that.
And then you can close the door too on the way out. Thank you. No worries. I'll finish this up. Okay, coming back. I do actually, illegally, but I'm not supposed to.
Oh, you're not supposed to really?
No.
No idea. They would strip that, you guys. But
I had to cover it up.
it's hard for subs because we always have to go to the office.
I know. It'll fit there. Some stuff I'm not.
Okay, so D6, right?
Yes, I just need you to say dance room. Yeah, that goes to my other room.
Okay. All right, thank you so much for coming.
Yeah, no worries. Okay, so once again, position is a vector quantity because it has magnitude and direction, typically. Yeah, if I have a negative position, that means like I was starting behind the meter stick. Positive position was in front of the meter stick. So there's 2 kinds of a change in position we can talk about. Position is just one location. If I talk about a change in position, there's distance along the traveled path. So if I'm leaving like this and I like checked how far, I actually took steps on my Fitbit, yeah, or on my car, that would be how far I traveled along that path. It does have magnitude only, so it is a scalar quantity. Yeah, it doesn't tell me like, oh, I went 500 miles. Well, I could have gone 500 miles like this. It doesn't tell me the direction. Displacement, however, is a straight line connecting your start to your finish, and it does have magnitude and direction, so it is a vector quantity. What that means is, again, you can see the picture here. This is distance, maybe 500 miles. Don't know where, though. 500 miles could be there, could be there, could be there. There's no direction with it. But displacement is specifically straight line from A to B. That's the direction. And again, we're going to talk more about this in class. Units are obviously meters because it is talking about how far you're traveling. The variable, again, is x. Very confusing, I know, but that's what it is. We're going to skip this slide that says origin and direction of positive. We're going to come back to that later. You guys are going to do one more slide here in this video. So the next super duper important quantity is velocity. Velocity is a change in displacement over a change in time. We're going to make a note card for this after we fill this out. But velocity, once again, it has magnitude and direction because it is displacement, and displacement is a vector. So velocity is a vector quantity. Speed, however, is the scalar version of velocity and equals the change in distance over the change in time. So again, we're going to talk a lot more about this in class. This is just the upfront stuff. The important thing to remember is that velocity will tell us a direction of travel. So if I say -3 meters per second, again, that means I'm traveling in a negative direction. But speed will never have negatives on it. It will just be 3 meters per second. I don't know what direction. That's speed. However, when you're traveling in a straight line, velocity and speed do have the same magnitude. So again, -3 versus 3, well, if I'm traveling in a straight line, that's the same magnitude. 3 is the magnitude. A couple other vocab here. We talk about a constant velocity, which is a velocity that does not change, right? If I'm just on cruise control, yeah. We can also talk about an instantaneous velocity, which is the exact velocity at a specific time t. If I have a changing velocity, the instantaneous velocity is the velocity at that point. It might change later, but instantaneous means in that instant. And lastly, we can talk about an average velocity, which is the displacement of an object divided by the time interval of the travel. So even if my velocity is changing, over this time period, if I can see my total displacement divided by my total time, that'll give me the average. I want you guys to write this one down as well. Oh, it'll be on the note card. So last note card, and then this video is done. We're going to continue with this tomorrow. So last note card, the front, I want velocity and average velocity formulas. So the definition on the back side is change in displacement over change in time. Velocity is a vector quantity, tells us the direction of travel. Units are meters per second. So again, one formula for average velocity is change in displacement over change in time. Remember that little triangle, delta, is change. Yes, you read that, and that means change. Or this is the normal average formula, right? The first velocity plus the second velocity divided by 2. That's how you find an average, right? Taking the average of two things, add them together, divide by 2. So depending on the context, it'll be either one of these equals your average velocity. Okay, so I know that was a lot, but again, the point of this video is to get all this upfront information down, make your note cards, and then in class, we will continue to delve deeper into this.